All right, so here we are, I'm back again. Another one now. We're going to do the circle with the radius of square root 7. Well, let's see the number 7 and see what you think after that. Okay, now for the numeral number 7. Now for the number for numeral 7. Now the numeral for the number 7. All right, now for the numeral for the number 7. Again, this numeral, let's start it over. Okay, so here we are with the numeral 7. Okay, now we're going to do the numeral that represents the number 7. The 7th circle in the series with the radius of the square root of 7. So here we have the circle, 1, 2, 3, 4, 5, 6, 7. And again, this is a circle whose radius does not intersect the grid on any intersecting point. Again, this particular circle is one that doesn't intersect any spots. It's a floater, kind of is floating in between. The square root radius 7 circle is the same as the 6 and the 3 in that there are no particular lattice points where that circle intersects the grid. So it's kind of floating between those lattice points. And so what the designers of this symbol did was choose some points where that circle just is close to, but just outside of the circle. So let's just see where that circle fits. Let's start here. 1, 2, 3, 4, 5, 6, 7. And as we go up here, we notice on this second line that the circle is just kind of crossing at this point right here. Okay, right there. And then we're just going to go over and we see it exactly on the other side, the same thing. So the points that I'm going to use there is has the coordinates. The x is again 1.9, and we've been seeing 1.9 in a lot of the videos so far. And then the height is 2. So 1.9 and 2 are the coordinates for this point here. And here we are. Here we have negative 1.9 and 2. Number 7. Now we all know what the number 7 looks like basically, right? But there's always, for me, been a little bit of a question with number 7 because some people draw the number 7 with the line across the middle. I don't, or never did. Now I do. And you know why I do? Because I think that's the right official way to do it. Here's why. Now when I first came on the number 7, I know what it looked like, and I thought it was up here somewhere. You go across and down, and I was trying to draw, but it never quite looked right, and so I just kept playing around, and it took a while. I mean, you look at it after and you go, why did it take a while? It's so obvious. Okay, so I'm back again. I'm doing this little series outside here in the dark as the sun's already set. It's kind of cold. And I'm having sort of a bad day, but it's okay. I just wanted to share with you what I got recently. I got to keep going forward with this whole project. So guess what number circle that is? It's the circle with the square root radius. I keep saying it wrong too, even. The radius 7. No, square root 7 radius circle. And so that's what I've come up with why the number 7 looks like it does. The number, it looks kind of standoffish to me in a way. It's really like backing away from the circle. It would be the most distant number. I mean, the 6 is just one line, but it seems to at least be touching the circle. I don't know. It's standoffish. Separate. But it does have the number 7 incorporated in that from here. 1, 2, 3, 4, 5, 6, 7. That's how tall it is. It's 7 units tall. So that's something. And that explains why it's got that cross, that line over it. I was wondering if maybe, how would I improve that number? Is there anything? I mean, I've been having an argument with someone. Not so much an argument, a discussion about this number. They were, okay, so you got that. You can always go back to the beginning of the video. They're saying, because I've been trying a few different versions, and for a while I was like, yeah, it's really obvious, and then I was drawing something completely different, or not completely different, but okay, so same as like the 3, kind of. There's where the number 7 touches the circle, out to here, and down to there. And now you can see why you need that centerpiece right there. Boom. And the reason why you have that middle section there is that you think about these 3 points, 3 points. You got the curve of the circle defined right there. And you can also kind of see how this lines up nicely. It's a beautiful symbol, and it's different from all the others. So that's why the 7th circle with the square root of 7 has a symbol that looks like a 7. Well, that's not the reason. They made it that way. I was placing it differently, but then I realized that the number, all the numbers, then I realized about number 5 and number 3 that they actually had the corresponding number of squares in the symbol. So then number 1 did, number 2 does, then 3, 4 has 2 all over it, square root of 4 being 2, 5, 6, I'm just still working on. I just talked about that a minute ago. So 7, this is the version that has 7 in it. 8 also doesn't really, I don't know, I think I got 8. It's pretty, seems obvious. Two radius circles. The line through them has the diameter in it. So I was thinking maybe for 7, see that? That has the diameter in it. It doesn't have in the line like that. So which of those versions is better? See, I don't like that middle line so much because it just says 2. What does the number 2 have to do with 7? I mean, it does sort of set the scale in a way. But this one's very much longer. I think I mean, again, how do you know? These numbers have evolved over time. So to look at modern versions and say, well, that's the version, nobody seems to know, or whoever does know isn't telling anyone. So that's another possibility. Okay. All right. So now I'm going to show you something really interesting. If I take a compass and I place it at that spot right there, 1.9 and 2 up, and I make it there, and if I was to just draw a line to here, I could see that it's going to hit this spot right there, okay? So I'm going to make a mark right there. Okay, so I've drawn a line from this point here all the way down to a point down here. You can't even see it. There you go, right there. Okay, so what's interesting about that line is that it is 1, 2, 3, 4, 5, 6, 7 in height. Okay, so we have a length here that's 3.5. We have a length to this point that is also 3.5, but you know what? It's not quite. So again, that close. But the fact is that we want to still delineate that spot. So I'm going to draw a line across here like this. So again, this is the same angle as all these other lines. See, this line is paralleling that one. It's got the same slope of going down 12 over 7, down 12 over 7, down 12, and over 7. And we see that it intersects right here, and either side of that point is 0.7 to these angle lines. So this little bar here is 0.7 on either side. Okay, again, we're incorporating the decimal value of the number. Let's put the grid behind and see what that looks like. Okay, so there's the number 7, or the numeral 7, with all its correct proportions. Okay, so 7 is probably the trickiest one, and that probably took me the longest. And to be honest, I'm still a little bit, I think, because in a way you can do a couple versions in a sense. Like we're 3 in from the side, so that's 9, or 0.9, and then 1. Another 1 is 2.9, plus another 0.9 is 3.6. 3.5, basically. So 3.5 times 2 is 7. There's any really a right or a wrong, but what I want to show you now is what I've come up with for a shape that has both the length of 7 incorporated into it in terms of the length of the lines themselves, and then it also incorporates just 7 in terms of like the 8, how it has it from the top to the bottom of the number. It's sitting in a space that takes up 7 units, so it's like it's got all these 7s just inside it. 7. So we got the length of 7 is incorporated in the total height of the numeral from the top to the bottom is 7 units high. We have 0.7 on either side of this from there if we measure over. So this length of line is 2 times 0.7, which is basically 1.2 in duodecimal. If I put a compass there and drew this line down, this is that same line again that was in the 3 and the 4, that angle of down 1 and over 0.7. So go down 1.7 again. It also explains why there's that line across the middle. And so, without further ado, here's my most recent version of why the number 7 looks like it does. Okay, so we're going to start with that top line, which is basically the top line of the circle. It's not the radius, but it's a line. And again, because the 7 doesn't have any intersecting points where it's actually crossing the plane, it's a little bit difficult to get exact lines. So that's the trick with these ones. The 7, the 6, and the 3 are all circles that don't cross intersecting points on the grid, and so they're a little bit tricky to find a real definite relationship. Like, even though we don't know, say, the square root of 2, it's very easy to find an exact spot. Like, you know, by we already know we've done the square root of 2. Okay, so number 7. Why does it look like it does? I thought maybe on this one, if you had that little notch at the beginning, but I don't know if I like that. It's a little bit messy somehow. So what we can do actually is just check something out by putting a compass here that is the length of 3.6, and if I was to just drop that down to this point here, we see that you know, 3.6 and 3.6, if we add those two together, we're going to get a length of 7. I'm going to use my straight edge and just go atop those 2 points there. So that's the first part. Now what's interesting, one of the reasons, I'll just share this with you, that I was debating a little bit, is because the distance between the underneath there, that from there to there, is exactly 4. And I was thinking, okay, that's a good number to start with if you want to create a number, if you are trying to create a length of 4. I don't know if we've done, I know I've done 5. I don't know if we've done 5 yet, but I'll let you in on a secret if you haven't seen 5 yet. That top right angle shape, that's number 5. When you add that length together, the top and then the other part of the right angle, that length is 5 exactly. So that gave me some clues to 7 here, because 7 is basically just 2 lines, and somehow those 2 lines need to add up to 7. But the trouble is, it's too long. I mean, it's going to be longer than 7. So we're going to have to break that line up somehow. Okay, so maybe that's why it has a line in the middle somewhere. It says, look at, stop, 7 is here, and then the rest, you don't, you know, it's extra somehow. So, given that, and given that we're trying to, we know what a 7 looks like, right? I've said this before, basically. Not everybody draws their 7s the same. Not everybody has that line in the center. So I could just draw a line from there to there, you know, and just be done with it and say, okay, that's the 7. That's kind of like, but I think that's like the 8 when you draw a line across and then 2 half circles. It's kind of like the shorthand version, and I want one that incorporates the number 7 in its length. So let's see what I can come up with here. I'm just going to get my compass, and I'll be right back. Okay, I'm back, and maybe you're thinking, why does he need a compass to draw number 7? It's pretty obvious what it is, you know, it's a straight line. But I'll show you why. If you measure okay, now if we measure this length there, and I go down here and make a mark. Okay, I just made a little mark. I don't know if you can see it so much. I'm gonna make it a bit bigger so you can see that mark there. Now what that is, I said already that this length here is 4. So this length here is very close to 3.5. 3.5 times 2 is 7. So what they did, as far as I can understand, is they said, okay, well let's just run that point through there. One, two, three, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're going to run a line through there that's 7 distance from there to there. And then this length from there to there is the length of 7. And then we'll just make a mark across there that says, hey, that's where this 7 length stops. Just to say, look, we got the 7 incorporated in there. So that's it. That's why the number 7 looks the way it does. I think that's the right way to do it. It's got the length of 7 like units incorporated in that angle. It's sitting on, from here to there it's 7. It touches the circle in 2 points. No, well, yeah, 2. Doesn't really go through there. I don't know if it's supposed to or not. I mean, these are things you can sort of play around with it a little bit, and a little bit of it depends on how accurate my grid is. When you start to draw, I just use this to draw the grid, so it's not really close. And if you want to, there's something to actually play with at home, is to get graph paper and really get precise and start figuring out lengths. Dividing up those squares into smaller units, and you can see like, oh, well, what do you think? Maybe they did have it go from here somewhere different. Curious as if anyone has an opinion or wants to try and figure out themselves. That'll come later, but right now I'm going to just leave it at that and say that's why the number 7 looks the way it does. If you can see what's happening here, I'm going to use this same diagonal line that we just used in the last few numerals. So I'm going to go down 1 and over 0.7, 1, 2, 3, 4, 5, 6, 7, down 1 and over 1, 2, 3, 4, 5, 6, 7, and then down 1 over 7. And I'm just going to keep doing that, down 1 over 1, 2, 3, 4, 5, 6, 7, and again down 1, 1, 2, 3, 4, 5, 6, 7, once more, 1, 2, 3, 4, 5, 6, 7, and once more, 1, 1, 2, 3, 4, 5, 6, 7. Okay, so now I'm gonna connect all those lines, or connect all those points with one long line. I think I can just squeeze it in here as the total length of this t-square. All right, well, there we go. I'm just going to start it, and then there we go there. Just reinforce that line. Nice and dark. Okay, so this point here was so we want to make a mark there to delineate the difference between that part of the symbol and this part here. So we put a line right across there. So now we see the origin of why why the numeral 7 has that line across the center. And look at this, and this really nails home the whole 1 and 0.7, because from that point there on either side, if we go to where these points just happen to be sitting, that's 0.7. So we have a line here that has 0.7 on either side, the decimal version of this numeral. We have these two lines here that add up to 7, or pretty close to it. It's kind of like the numeral for the number 6, where you had that line that wasn't quite 6, but pretty darn close. All right, and so here we have the numeral that represents the number 7. When you see it on the grid, you see that it's actually 7 units tall. It has a height of 7. I'm just going to I've made 2 marks here. I'm going to draw a line right across the top here. Okay. So these marks are just on the outside of where that circle is intersecting that spot there and that spot there. So it's perfectly balanced. And basically the length of that line is 3.6. That spot is 1.9 from the center, and this is like minus 1.9 from that center. So the overall length of that line is 1.9 plus 1.9, which is 3.6 in duodecimal. 3.6 is 3.5. 3.5 times 2 is 7. So I don't know at what point in the video this is. I lost track. I'm just doing all the ones now that I haven't done before yet. So I only just figured this out. I spent last night really working it on graph paper, and I know that that top line is not exactly 3.5. Okay, it's really close. So it's a little bit short, I think. And so, and it doesn't go through this point exactly. So the only thing that's really exact is that it goes from here to there. So I think that might be why they said, look, if nothing else, we know that from the top to the bottom is 7. So we're definitely incorporating that number into the shape. All the rest is it's a little bit close, a little bit short, a little bit long. But basically, that's why the 7 has that angle across the middle, or that line across the middle. And it's got nothing to do with angles. Yes, and I can't show it on here because I got to get the wrong diagram. But I got another diagram in the back there that I'm working on, and it's just the scale is a little bit. It's so big, Like that's part of the challenge actually, is that I've been showing these diagrams on like graph paper that I'm just like, it's like, kind of like scrap paper that I'm just using with my ruler to make the graph. And so it's kind of like kindergarten style, I only have those big swaths of, big thick ink pens, and they're all a little bit off. I only have those lines to work with, and I'm realizing that there's subtleties here, where they're a little bit over, and they're on like this line. I don't have these lines on my homemade graph paper. And these lines are turning out to be actually quite important lines. And those are like duodecimal lines in a sense. They're based on that grid having the dimensions of, 12 by 12 squares. So the equilateral triangle for number 6 has the two sides on either side of the right angle are 4.3 in length, which is also so interesting because like here, the 3 you go over like 0.3. Okay, and so here's that numeral with all the coordinate points lined up there. Here we have 1.9 and 2 for the location of that spot, minus 1.9 and 2, 0 and minus 1 for the spot where this line intersects. Either side of that, minus 1 and 0.7, minus 1 and minus 0.7, and way down at the bottom here, we have minus 2.4 and minus 5. And I just wanted to show you, here I do a triangle, basically for this length here, to show that's the length of 3, this is 1.9, and that's exactly the same triangle that was in the number 4, or the numeral 4. Okay, and so that made this side here the square root of 10.09. Okay, so I'm going to go back into my basement, and I'm going to work out number 7, because I think I still don't have it. I think I got to make it bigger. What's bugging me is that cross bar. I feel like it has to be a certain length somehow to really be significant. I think that the number 7 being in it should be more precise. Yeah, so that's what I'm going to look for the number 7. Basically, some kind of perfectly drawn. I think it's going to incorporate these angle lines in it, maybe going through the center. Maybe that center line is the diameter of the circle, and I just got to make it bigger. So basically, this length here, if I was to draw a circle and go down here, it's very close to also 3.5. It's a little bit short, but 3.5 and 3.5 is 7. So similar to the 6, in that they're giving lines that are as close as they can approximate, they being whoever designed this. So, and just to show you how close it is, so that's 3.6, 3.6 squared is, this, let me get that, I get 10.3. 10.3, you know. So this line here, we go down 1, 2, 3. So 3 squared equals 9. And this from here over is, from here, that's 1.9. So 1.9 squared in duodecimal is 3.09. So you add those two together, so it's 9, A, B, 10, 10.09, 10.09. So this length here is this, you know, basically the square root of 10.3, and this line here from there to there is 10.09. So it's very close to 7 in total. Again, try fitting it into one of the other circles, just switching any two around even. Try to do that and see how well it works. You know, again, when you see it on the grid, you can see these lines coming down, have that slope also down 1 over 0.7, down 1 over 0.7. It really fits in that pattern. This angle here is the same as that, is the same also, down 1 over 0.7. So it's got 0.7 sort of encapsulated or as part of that slope. So again, numeral 7's got a slope of 1 over and 0.7, whole lot of 7 going on in there. Okay, the numeral 7. All right, that's why the number 7 looks the way it does. Let's do something else. Let's cut to some other information, and then I'm going to go and we'll do maybe, I don't know, maybe do something else. All right.